Hello and welcome to The Agenda. I'm Stephen Cole. Almost 50 years since man last walked on the lunar surface, humanity is ready to return to the moon, and this time perhaps stay a while. Today we look at Earth's closest neighbour, satellite and future home, away from home. We'll be speaking to China's National Space Administration about the plans for their latest lunar samples. Plus, the ISS has managed it, but is the moon's future one of international cooperation? And next stop, Mars. We'll be looking at the next frontier in space exploration.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Man has not set foot on the moon since NASA's Apollo 17 mission in 1972, almost 50 years ago. But it seemed that when the winners and losers of the Cold War-era space race became clear, interest in revisiting the moon started to fade. That is, until now. Last year, China planted its flag on the moon in December, before the Chang'e 5 space probe came back to Earth with samples of rock and soil from the lunar surface. Meanwhile, American space agency NASA revealed its plans to send astronauts back to the moon by 2024. The first phase of this mission, Artemis 1, will begin this year. NASA also announced agreements with Elon Musk's SpaceX, Jeff Bezos's Blue Origins, and aerospace veteran Dynetics. The combined $967 million contracts will see each of the three companies develop their own moon landers. And of course, the US and China aren't alone. Countries like Japan, Russia, and India have all outlined ambitious lunar missions launching later in 2021. So while the old plans were all about getting boots on the moon, the new rush to space has bigger and more long-term ambitions, like genuine international cooperation and creating a gateway to the next frontier, Mars. Not only will the moon serve as a critical testbed for systems like rovers, habitats, and power stations, it's also an essential stopover on the near 34 million-mile journey from Earth to the Red Planet. Last year, the European Space Agency published its concept for an international moon village, envisaged for sometime around 2050. It shows what life might be like for the first people living on the lunar surface. As it stands, humanity is limited to one planet, with a growing demand for finite resources, so space colonies could be the answer to this problem. NASA says that modeling life for astronauts on the moon will help future generations refine our knowledge of the Earth's ecology. In other words, the more we know about what is up there, the better things will be down here, on Earth. So, as we've heard, China is the country which has most recently been to the moon. The Chang'e probe returning to Earth with almost 2 kilos of rocks at the end of last year. Well, joining me now from Beijing is Xu Yansong, Director for International Cooperation at the China National Space Administration. First of all, China must have targeted this particular part of the moon for a specific reason. What do you hope to learn from these samples?
Well, I think there's a great interest in the international community to study these samples because of the geographic locations. This region is the newest region on the moon, some 1 billion year old in comparison with 3 to 4 billion years old. Those samples that has been collected by the former Soviet Union and US. So these samples are very useful for telling the moon's characters, the volcanic activities, and the later stage moon activities. We will distribute the sample to the international community. That is the preparation work we were doing now.
How important is global cooperation between China and Europe, China and US, etc.?
Well, I think global cooperation is essential for exploration missions. The moon is not far away from Earth. We can have independent missions, but to go further, we need to collect all the strength that we have on the Earth. So the cooperation with European, in particular European Space Agency, has been very successful. And before that, we also have Chang'e 4, which is also open for European cooperations, and four countries from Europe, namely Sweden, Germany, France, and Belgium, had also participated in this mission, putting instruments and payload on board the mission. And we are also looking forward to more extensive international cooperations once we have this opportunity. So this is a good opportunity to cooperate with Europeans, with Russians, with US. And we do have some difficulties cooperating with the US. But with the new administration, I certainly believe that the bilateral cooperation, the old mechanism between China and US in this civil coordination dialogue forum will continue, that the opportunities will be found between the two countries. So globally speaking, China is fully open for international cooperation on the Chang'e mission and beyond.
What about Mars? What are your plans for Mars?
Well, our Mars probe is on the way, and it is to be inserted into the Mars orbit on February 10th in the evening of China. So we're looking forward to the first mission of Mars. So this Mars mission included 3 segments: the orbiter, the lander, and the rover at the same time. So it's a first mission from China, but we are very ambitious. We put 3 segments together. And the Mars mission, we're looking forward to its landing maybe sometimes in late May of this year. So I certainly looking forward to a successful mission of the Tian-1, which is our Mars mission. And we are, based on the success of this mission, China will continue its Mars sample return missions. And this will be the nearest scenario for the Chinese Mars exploration program.
Xu Yansong, many thanks for joining us on the agenda.
Thank you.
So that's China's lunar ambitions, but what about the United States? To discuss NASA's Artemis 1 mission and more, I'm joined by the veteran space journalist Leonard David, and Leonard's in Colorado. Leonard, why has it taken so long for humans to go back to the moon?
Well, there's quite a number of reasons why, but I think if you go back and look at what we accomplished in the United States with putting a number of crews on the moon, but the last mission was December of '72, Apollo 17. So you're right on. It's been a long time. The big difference this time around, however, is to stay and not plant a flag, kick up the lunar dust, and then depart. So there's a big agenda, and it's not only the United States, but China, Europe, Russia, other countries. So it's an exciting time. I'm ready to see it all happen again.
A number of countries this time, it's not just the US head-to-head with the Soviet Union, a number of countries, a number of individuals, all bidding to get up there into orbit, into the lunar space. What's driving them?
The moon is not a been there, done that place. There's still a lot of mystery that's going to be available for new discovery. We have certainly learned more about the moon thanks to the Apollo samples, and China has just brought back a number of new samples. So the moon is still revealing itself. We're not even sure how it formed. So I think we've got a lot of science that can be done. But one thing that's happening is the private sector is very interested in perhaps setting up mining operations on the moon. You transform lunar ice that's buried in these darkened craters at the poles of the moon. And if you have access to that kind of resource and other material that may lurk on the moon that we're not aware of, I think you can make a pretty good case that the moon is going to be a much different place in the 21st century as we close it out.
So all these missions, are they driven by, I want to be the first, perhaps by individuals, or is it commerce or science?
I think it's going to be a little of everything: commerce, science, and just sheer exploration. And, you know, by the way, the moon is pretty close. I'm a big Mars person, you know, blueprinting a plan for the red planet, and that's going to happen as well. But we're going to get our lunar legs underneath us this time much better to train for Mars.
Okay, so the moon was the original target. Mars, forget it. Now, Mars is within grasp. Is it compelling enough to grasp our imagination, grab our attention, as the original Apollo series did?
I believe we're seeing something new. I like kind of now history. For the first time, we all can explore the internet, camera systems, listening devices on these spacecraft. We're all going to be taking part in exploration of not only the moon, but Mars. And I think it's going to give us a wellspring of knowledge and excitement about what humans can do. What
is the level of cooperation internationally to get people up to Mars?
Well, I think there's tremendous amount of literature now that has been evolved. The International Space Station, where you have multiple countries involved, has been a kind of a testing ground for a lot of technology, life support systems, and also understanding the challenges that are ahead: radiation exposure, the microgravity and its impact on the human body. So the space station that's there, and then China is about ready to launch their own facility, those are great testing grounds for hardware and the people. So we're flight qualifying the next generation of astronauts that will actually set foot on Mars.
Incredible. Leonard, David, many thanks to you for joining us on The Agenda.
Thank you for having me.
The space industry is thought to be worth as much as $400 billion. Sectors like defense, IT hardware, tourism, and even mining are all areas that could cash in on a new wave of space exploration. Well, joining me now to discuss this and much more is Bernard Hoffenbach from the Commercial and Innovation Team at the European Space Agency. Bernard, we mentioned the lunar economy earlier. What does that mean to you? How would you describe the lunar economy?
So for me, the lunar economy is nothing else than an extension of a terrestrial economy to the cislunar space. Moon in future may open new market opportunities, but we need to keep in mind all the economic activities and the jobs are still on Earth.
Commercialism of space, a lunar economy, inevitably means space competition, doesn't it? Is that a good thing for driving space exploration?
In exploration, we always need both cooperation and competition. Without competition, we don't drive innovation. We need cooperation between international partners, but we also need industry-to-industry cooperation beyond national boundaries to ensure that we have the end-to-end supply chains we need for future space exploration. But without competition, there is no innovation for space exploration.
And what sort of commercial partnerships is the European Space Agency interested in going forward?
We are interested in any commercial partnership which is founded on a solid business case. Actually, we are listening to the European space industry. They're making proposals to us, and we do assess those proposals. Currently, when it comes to the moon, we're working on 3 topics. We're trying to assess whether we can commercially establish a service for lunar communication navigation, which is very important to connect the Earth more closely with the moon. We are working on the production of a fuel, which will in future be used for radioisotopic devices, which power future lunar assets and support the thermal control. But we also try to see how we can position European industry in the value chain of future transportation services, delivering science, cargo, and technology to the lunar surface.
So which sort of industries do you think are likely to benefit the most from a lunar economy? I'm thinking satellite communications, perhaps, navigation infrastructures.
Well, of course, there is a classical space industry building habitats and transportation system. They benefit first. The classical industry providing communication navigation service on Earth can extend their business into deep space. That's clearly a strong business opportunity. And I think a strong business opportunity is everything related to the use of space resources. And here I talk about the mining industry, robotics, industrial processing, and artificial intelligence. So there are lots of industries which are today grounded in a terrestrial sector, which may discover opportunities once we start permanent operation on the lunar surface.
Can you name one, then, Bernard, one major advantage we'll feel the effects of, or the benefit of, down here on Earth from what is going on up there in the sky?
Well, firstly, there's an economic benefit. It's innovation, technology innovation, jobs on Earth. But honestly, ultimately, exploration of space is an inspiration for our society. In particular, in a crisis like this, we know our future is grounded in science and technology. And space exploration is a clear symbol of what we can achieve if we focus on science, technology, and innovation.
As you know, we're approaching a green year, 2021. Lots of hopes that we'll have a greener and a safer economy and perhaps a reduction of climate change. A lot of efforts going into that. What about sustainability in lunar terms? Is that important?
Sustainable is important. Without sustainable exploration, we will never create an economy. It's maybe an interesting idea. Whenever we start operating on the moon, we need to create a carbon-free economy because there's no carbon to burn. So we will need to find new technology solutions to sustain human robotic operation on the moon, which also create linkages to addressing climate change topics here on Earth.
Bernard Hoffenbach from the European Space Agency. Thanks for joining us on The Agenda.
You're most welcome. Thank you for the opportunity.
Still to come here on The Agenda, how long before we send humans to the moon permanently? We'll be speaking to two of Britain's leading voices on lunar exploration.
The agreement is signed. But what is the real deal now the UK has left the EU? For trade, for business, for the city, for ordinary people. Make sense of Brexit with CGTN.
Welcome back to The Agenda. Before the break, we heard about the lunar ambitions of China, Europe and the US. For more, though, on the business of the moon and living in space, I'm joined by the director of the UK's National Space Academy at Leicester University, Professor Anu Oja, and space journalist Sarah Cruddas. And Sarah, I'll start with you. Tell us more about the missions to the moon this year.
One of the missions I'm most excited about for 2021 is the Commercial Lunar Payload Services, which is with NASA, because what we're actually seeing is just with exploration on Earth, governments going first and then private industry follows. So we're going to see private missions through NASA actually landing on the surface of the moon. So changing who can access the moon. It's no longer just about governments, but also private industry. But we're also going to see more and more countries looking at going to the moon. So Russia this year is returning to the moon. They haven't been for some decades. They're actually going to be landing a rover on the surface of the moon. And we're going to see also an Indian mission to the moon and just more excitement about the potential of what can be done on the moon, looking at resources on the moon.
That's so interesting. It's something I want to put to Professor Oja as well. Professor Oja, man hasn't set foot on the moon for half a century. Why the sudden or renewed interest in the moon?
50 years ago, when 24 humans went to the moon and 12 walked on its surface, that was primarily driven by geopolitical considerations. It was part of the Cold War, so it was the Soviet Union, the United States. And the irony is, although it was a politically driven program, the science yield was absolutely transformational because, especially in the last three lunar landing missions, Apollos 15 to 17, with 3 days spent on the lunar surface, extensive geological training, it's fair to say that many of the mysteries surrounding the origin of the moon and the Earth-Moon system, we got crucial insights from that data trove 50 years ago, specifically from those last three Apollo missions. Now, politics being politics, when the political impetus stops, it's fair to say that we changed our foci, both the Soviet Union and the United States. And of course, there was a bit of a hiatus, nearly 20 years. But then we started to get robotic missions in the 1990s and orbiting missions. And what we found is the moon is far more interesting than we thought it was. Whenever we make new discoveries, we have new mysteries that emerge. And one of the things about the Earth-Moon system is that the moon is like a geological time capsule. of Earth's early history, because of course on Earth we've had active weathering for billions of years. On the moon, pick up a lunar rock and the chances are it's been undisturbed, it's pristine. And so by understanding these ancient samples of lunar material, like the ones brought back by Chang'e 5 very recently by China, what we get is a better insight not only into the moon, but the early history of the solar system, the early history of planet Earth. And if we want to understand Earth's potential future, comparative planetology, that means comparing Earth to other planets and their satellites, is absolutely key. So from the science perspective, from geopolitical considerations perspective, this renaissance of a focus on the moon is exciting for all sorts of reasons.
Indeed. Sarah Cruddas, you heard Professor Oja there say the moon is far more interesting than we had originally thought. And that immediately provokes my thought that have we barely scratched the surface in terms of resources and what the possible resources the moon could provide?
One of the reasons we go into space, of course, is to benefit life on Earth and to extend humanity's presence. But there's also this very fundamental stuff that humans have wondered since the dawn of our existence, such as where do we come from? Why do we exist? What else is out there? And it's by studying the moon, which could have been dismissed as a lump of rock only a matter of a century ago, that we actually learn more about ourselves and the history of Earth and where we potentially came from as a species. And then we also go to the moon because there's the potential, to extend humanity beyond Earth. If we want to see human beings walk on the surface of Mars, and when I was growing up in the 90s at least, I thought by 2020 we'd see human beings on Mars. We've always been told it's the next few decades away, but if we really want to see that happen, we need to go to the moon. That's what it's looking like, and we need to learn how to live away from Earth for long periods of time and extend what we're able to do and to live off the land. Because when people explored the Earth, they didn't take everything they needed with them. They lived off the land, and we need to be able to do the same on the moon. So the presence of water ice, for example, that can be used for oxygen. It can be used potentially even for rocket fuels. Yeah. So it enables us to potentially use the moon as an intergalactic petrol station, so to speak, to enable us to actually go further into the solar system.
So very much a staging post, perhaps, to Mars. Professor Oja, is it true that the more we know about the moon, the more we will understand about the Earth?
The presence of the moon has been effectively like a little bit of an anchor on the Earth's axial tilt. So the Earth's axial tilt is what gives us seasons. And, astrodynamic modeling suggests that if we didn't have a moon, then we'd still have an axial tilt, but it might be a lot more variable than it is now. Therefore, we'd be a lot more prone to much more rapid climate change. I'm talking geological climate change over millions of years, not over the case of just a few decades. But that's just one example of how understanding the moon has given us new insights into the Earth itself. And as Sarah said, the discovery of volatiles on the moon, so materials that we can easily, they might be frozen, but we can easily get them in the liquid phase, and then we can do our chemistry to get hydrogen and oxygen from them. The discovery of volatiles, specifically around the south polar region of the moon, means that, as Sarah says, we're not just going to go for 3-day landing missions like the last few Apollo missions, but we can get human presence on the moon from a science perspective for months at a time. And I'm confident that if we have this discussion in, let's say, 10 years' time, Stephen, that we will have the equivalent of the International Space Station on the lunar surface. Well, we'll have astronauts, cosmonauts rotating for months at a time, and our science yield is going to be tremendous.
And Sarah, what about international colonization up there in space? And also Artemis 1, which Professor Oja mentioned, the first woman to set foot on the moon. That's all planned, isn't it?
Well, I actually look forward to a day when we're no longer celebrating women's achievements, but it's actually women smashing barriers for humanity, and hopefully that will come through the next few decades. But in terms of colonization, it's an interesting thing, because I think there's some great points there. There's that cliche line, and sometimes I'm guilty of using it, that the ISS is worthy in many ways of a Nobel Peace Prize, because you've got those nations working together. But it'd be naive to say that people are going to get on together as we continue to expand beyond Earth and further into the solar systems.
But I want to go to Professor Oja, because I want to talk about the people you're teaching to be the next generation of space astronauts, space engineers. Do you think it would be too soon to suggest they could be the first real generation of spacefarers?
You know, astronautics is just one side of space science. Space science is astronomy, looking out there. It's exploration, going out there, but it's also the satellites looking back here at Earth, so satellite applications. And we're trying to train engineers and scientists who work across that field, that swathe of space sciences, but much further than that, because even if our students don't go into space sciences, but if they go into anything to do with science or engineering or mathematics, then they are developing skill sets that are contributing to the foundations of our modern way of life. Because astronauts are so visible, and as humans we can relate to them, there's going to be that much more of a visible draw for students to realize, you know, by developing my skill sets in science and engineering, there is a world of possibilities open to me.
Exactly, and as Mr. Spock would say, that's the logical explanation. I just want to finish with Sarah, very briefly, Sarah. What's more important, the moon or Mars now?
Mars is hugely exciting because Mars and some other places in our solar system, those could be the places where we get that clinching piece of evidence to say, do you know what, humanity isn't alone. There is life elsewhere in the solar system, potentially microbial life or life that exists in the past, which is independent of life on Earth, and that could answer some profound questions. But the reality is, the less sexy side is, I guess, that it's more practical to return to the moon, this time stay for good, extend humanity's presence beyond Earth, and then look to going to Mars. But the reality is, human beings are social creatures, and I think it's step by step, ferociously, that we have to take this, and the moon is that next step. But the ultimate goal is Mars, and to be able to one day look up at the night sky, see Mars as that red star-like object, and know that there's human beings there, that will be incredible. But I think we're still a few decades away, but I think we'll get there eventually. And then, of course, Mars is only just the beginning. You know, it'll take many human lifetimes to even begin to explore much of the solar system, and that's what's so exciting, because all of us are the space generation. We are living in the space age now, and all of us can be a part of it.
Sarah Cruddas and Professor Oja, thank you both very much for joining us here on The Agenda.
Thank you.
Thank you.
So, nearly half a century after man first set foot on the moon, it looks as though humans will be back on the lunar surface in a matter of years. And where once it was just the US, Russia and China heading into orbit, now Europe, Japan and India are joining the party. And where once the drive to the moon seemed largely political, now it seems the Earth's only natural satellite will be an opportunity for truly global cooperation, just like the International Space Station. China has already announced plans to share the samples from last year's Chang'e 5 mission with the international scientific community, hoping to advance not only our understanding of the moon, but also more about life here on Earth. And of course, these lunar missions are just the first step towards the next human first, setting foot on Mars. For some scientists, there is no doubt that humans will be living in space in the next century. Within 2 or 3 generations, 1 million people could be living on the red planet, our home away from home. We've waited decades for thrilling new manned missions to space, and now several are coming along at once. Indeed, spending on space looks set to outstrip overall global economic growth in the next few years, as private and public money is poured into efforts to send humans millions of miles from their home planet. Settling in space may be humanity's greatest challenge yet, and while it's an exciting one, we should perhaps also be cautious about seeing it as the solution to end our problems on Earth. Coping with climate change may seem daunting, but it seems a simple task compared to surviving on Mars. Don't forget you can watch everything from past Agenda episodes and find additional exclusive content on our website, cgtn.com/Europe, or on our YouTube channel. And of course, you can follow us on Twitter, Facebook, Instagram, @CGTN Europe. Coming up on a future agenda, the road to immunity. How soon can vaccines end the COVID pandemic? But for now, from me, Stephen Cole, and all the Agenda team here in London, it's goodbye.